welcome to this class. My name is Mobani Kestin and I'll be taking you on the subject chemistry. In this lesson, we'll be looking at the theme chemistry and industry, and we'll be looking at the topic metals and their compounds, part 4. We've gone through part 1 to 3 where we talked about the metals, the group 1 elements, group 2 elements, and in this lesson, we'll be talking about the group 3 elements. So by the end of this lesson, you should be able to state the properties of aluminium as a member of the group 3 elements, okay? You should also be able to describe the extraction of aluminium, identify some compounds of aluminium, and identify some of the uses of aluminium. So let us look at the group 3 elements generally. The group 3 elements have 3 valence electrons in their outermost shell. Okay, so we know that the group 1 elements have 1 valence electron, the group 2 elements have 2 valence electrons, and the group 3 elements have 3 valence electrons. Now, elements in this group are boron, aluminium, gallium, indium, and thallium, as represented in this diagram. Now, this group, as their atomic number increases down the group, their metallic property increases as well. So this means that boron, okay, which is at the topmost of this group, is going to be a metalloid, while aluminium, okay, and the rest of these elements down the group are going to be metals, okay? And it also means, remember we said that the metallic property increases down the group. So this metal is going to be more metallic than this, okay? Thallium is going to be more metallic than indium. Indium is going to be more metallic than gallium. And gallium is going to be more metallic than aluminium. Up here, boron is a metalloid, all right? So that's that about the group 3 elements. Now, looking specifically at the elements aluminium as a member of this group, say that aluminium is a metal found, of course, in the group 3 on the periodic table, okay? Now, aluminium is the most common metal in the Earth crust as it makes up 7.5% by mass. So, aluminium is the most abundant element in the Earth crust, all right? Now, aluminium has a lot of ores. There are several ores from which aluminium can be extracted from, okay? But the chief ore from which aluminium is extracted from is the bauxite, okay? Which is actually aluminium oxide dihydrate. It's an ore that can be seen as an impure aluminium oxide, and it is found mainly in rocks and in clays. Okay, that's the bauxite ore. Other important ores from which aluminium can be extracted from are kaolin, all right, which we have here, okay. We have the cryolite, all right, another ore from which aluminium is extracted. We have corundum, and we have mica. All these are important ores from which aluminium is extracted from. Now, aluminium has an atomic number of 13 and has an atomic mass of 26.982. So that's what we have generally on aluminiums. Now let's look at the properties. Of course, aluminum is a metal, okay, so it's going to have the property that all other metals have. Now, pure aluminium is a silvery white metal that is relatively soft, okay. It has a low density. Aluminium is resistant to corrosion. Now, this is due to the thin layer of oxides, okay, that usually forms on its surface. Now, this thin layer of oxide usually stops air and moisture from getting to the metal. We know that the main cause of rust is what? The presence of air, actually oxygen, and moisture on a metal, all right? These two, when they are together on a metal, it causes rust to occur on that metal. But we are saying that aluminium is resistant to what? Rust, because it has a thin layer of oxides on the surface that stops air and moisture from getting to the metal itself, so it doesn't rust easily. Aluminium is a good conductor of heat and electricity. Of course, it's a metal. Most metals are good conductors of heat and electricity. Aluminium is malleable and ductile. It burns in air at high temperatures to form its oxide and nitride. All right? It reacts rapidly with concentrated acids such as hydrochloric acid to displace hydrogen. All right? So with concentrated hydrochloric acid, aluminium will react to what? Displace the hydrogen. So it will form aluminium chloride. All right? But with dilute acids, okay, it will react more slowly. It combines directly with nonmetals such as sulfur, nitrogen, carbon, phosphorus, and halogens, okay, such as chlorine, on heating to give off heat. So when aluminium reacts with nonmetals, all right, it gives off heat. Aluminium has a melting point of 660 degrees Celsius and a boiling point of 2,470 degrees Celsius. Now we'll be looking at the extraction of aluminium. Now aluminium is one of the most reactive elements, as you can see on the reactivity series on the board here. We have aluminium here, so it falls under the very reactive elements, and these elements are usually extracted by electrolysis. All right, so it is more reactive than carbon, so we can't use carbon reduction for it. We have to use electrolysis to extract aluminium. There are two stages extraction of aluminium goes through. All right, it is extracted from bauxite, and these two stages of extraction are: one, purification of the bauxite to yield pure anhydrous aluminium oxide. So the bauxite ore needs to be purified first. After that, the second stage, which is also the final stage, is the main electrolysis to get the pure aluminium metal. Now, we'll be looking at the first stage, which is the purifying of the bauxite, okay? And it is done by the Bayer process. Now, this raw ore, of course, the bauxite, will be crushed into powdered form, okay? After it is crushed, it is heated in a solution of concentrated caustic soda under pressure to form what? Soluble sodium aluminate. All right? So this bauxite, when crushed and heated in a solution of this chemical, caustic soda, it forms sodium aluminate, and this sodium aluminate is what? Soluble. So we have the bauxite reacting with sodium hydroxide, of course in water, to form sodium aluminate. The impurities formed in this process, okay, will be filtered off as sludge. So we now have our sodium aluminate, right? Now, this filtrate, which is the sodium aluminate, of course, when filtration occurs, what we have is the what? The filtrate. This filtrate, of course, which contains the aluminate 3, is cooled. So after it is heated, it is allowed to cool down. All right? Now, crystals of aluminium hydroxide are introduced into the cooled filtrate. All right? It's introduced into the cooled sodium aluminate. These crystals serve as what? A material on which new aluminium hydroxide is going to what? Precipitate around during the reaction. So we are saying that the sodium aluminate, after it has been cooled, all right, we need aluminium hydroxide to precipitate out of this solution. But then it may not be able to precipitate on its own. So we have an already prepared aluminium hydroxide crystal, okay, at hand. So we add it to the cooled sodium aluminate. Now this aluminium hydroxide we are adding is so that the new aluminium hydroxide that is going to form would have a basis, a ground on which it will precipitate around. So we have this sodium aluminate. When we add the crystals of aluminium hydroxide, we have aluminium hydroxide as well, precipitating out of the solution. And we have sodium hydroxide as another product there. So now this aluminium hydroxide precipitate, of course, is now filtered off, washed. Of course, that is actually what we are looking for, the aluminium hydroxide. It is filtered off, washed, dried, and then heated strongly again. Now, when it is heated, this process is now going to yield pure aluminium oxide. All right? The sodium hydroxide, of course, that we saw that was formed can be concentrated and used again for this process. So this aluminium oxide formed now undergoes electrolysis to yield the pure aluminium metal. So this is the first stage on the extraction of aluminium. We got the bauxite, we concentrated it, and we treated it with a chemical, and sodium aluminate was formed. That sodium aluminate formed was allowed to cool, and crystals of aluminium hydroxide was added for a precipitate of aluminium hydroxide again to be formed. All right? Now, that aluminium hydroxide that precipitated out of the sodium aluminate was filtered off and washed, dried, and heated again. Now, it was after it was heated that it now yielded pure aluminium oxide. All right? Now, this pure aluminium oxide is now what is going to undergo electrolysis for pure aluminium metal to be formed. Now, let us look at the second stage, which is electrolysis of alumina. Now, this aluminium oxide formed after purification, okay, is mixed with what? Cryolite. Now, this is going to form what? Our electrolyte. Remember, we are talking about electrolysis now. So we are talking about an electrolytic cell that comprises the electrolytes and the electrodes. This aluminium oxide and cryolite, which is actually sodium aluminum fluoride, is going to form what? Our electrolyte. Now, this sodium aluminum fluoride is added to lower the melting point from 2000 degrees Celsius to 1000 degrees Celsius. Now, this solution is heated and the molten liquid is used as the electrolyte in this process. All right? So for this electrolysis, we are saying that the electrolyte is going to be what? The aluminium oxide and cryolite heated, and then the liquid that we get from the heating is forming our electrolyte. So the electrolytic cell consists of electrodes made of graphite, which is carbon. So both ends, the cathode and the anode, are made of graphite. Now, the graphite lining serves as the cathode. As you can see here, we have graphite lining here serving as a cathode, while the graphite rods dipped into the electrolyte. As you can see, we have graphite rods. These are graphite rods dipped into what? The electrolyte. Here we have our electrolyte, of course. So these graphite rods, okay, forms the anode, while the graphite linings here form the cathode. So let's see what happens. During the electrolytic process, the ore is decomposed into what? Ions, which are the aluminium and oxygen ions. All right? So we'll have them forming this, okay? And then we'll have our oxygen ion as well. So what happens? They've dissociated into their respective ions. All right? So the aluminium, which of course a positive ion, is going to go towards the negative electrode, while the oxygen ions, which is negative, is going to go towards the positive electrode. Here is our electrolytic cell, as we have pointed out. So at the anode, at these anodes, what happens is that the oxygen ions move to the anodes, and then they are given off as what? oxygen atoms. Now, these oxygen atoms formed at the anode will constantly react with the graphite. Remember, we said that graphite is actually carbon. So this oxygen is going to be reacting with the carbon to form carbon dioxide. Okay? It's going to be reacting with that carbon to form carbon dioxide. So this means that the anode will constantly get what? Used up. The carbon will constantly react with the oxygen to form carbon dioxide. So we don't have carbon there anymore. What we'll be having as the reaction continues is what? Carbon dioxide. So the anode is being what? Depleted. So in order to caution this effect, it means that the carbon, okay, the anode will need to be continuously replaced for the electrolytic process to continue. So this is what happens at what? The anode. All right? Now, at the cathode, the aluminium ions will move to the cathode. All right? So we'll have the ions coming to the cathode. They are going to gain electrons to become reduced to what? Aluminium metal. So what happens at the cathode is a reduction reaction, while what happens at the anode is an oxidation reaction. All right? So the aluminium ion gets reduced to aluminium metal. Now, this aluminium metal is, of course, in a molten state, somewhat in a liquid state, right? So this aluminium will now sink to the bottom of this electrolytic cell. And from here, it will be tapped off, all right? So the aluminium metal formed at these cathodes will sink to the bottom of this cell. And it will now come out from here in its molten state. So this is basically what happens in the extraction of aluminium. So the general reaction, the chemistry of reaction will have the aluminium oxide being dissociated into the various ions, aluminium ion and oxygen ion. Okay, at the anode, of course, oxidation takes place and oxygen reacts with the carbon to form carbon dioxide, while at the cathode, reduction takes place where the aluminium ion gets reduced to the aluminium metal. So we'll be looking at some compounds that aluminium form with other elements. Now, aluminium usually forms covalent compounds, but when it forms ionic compounds, it exists as a trivalent ion. So this means that when it forms ionic compounds, it does so with all three valence electrons. Now, some of the compounds that aluminium form are aluminium oxide, aluminium chloride, aluminium hydroxide, aluminium tetraoxosulfate 6, and aluminium trioxynitrate 5. These are not all the compounds, but we're just going to be taking these for the sake of this lesson. So let us quickly take a look at each of these compounds, how they are formed and their uses. Now, aluminium oxide. This compound is a white crystalline powder commonly known as alumina. Of course, it's from here that we do most of the extraction for aluminium metal. All right? Now, it occurs naturally as bauxite, the aluminium ore, can also occur as corundum and white sapphire. But in the lab, aluminium oxide can be prepared by heating aluminium hydroxide or other compounds of aluminium. So we have aluminium hydroxide. When it is heated, it decomposes into aluminium oxide and steam. Okay? So aluminium oxide is an amphoteric compound. This simply means that it's a substance that has the ability to react as an acid or as a base. For example, in this reaction, aluminium oxide and fluoric acid, the aluminium oxide here is reacting as a base. Of course, fluoric acid is an acid. So here it is reacting with fluoric acid to give aluminum fluoride and water. But in this second reaction, aluminium oxide and sodium hydroxide, this sodium hydroxide is already a base. Here, aluminium oxide is reacting as what? An acid. And when it reacts with this base and water, it will give us sodium aluminate. Of course, sodium aluminate that we know, that we've talked about. Now, aluminium oxide is used in the extraction of aluminium. Of course, we saw how that we extract aluminium from aluminium oxide in the electrolytic process. So it is used when we want to extract the pure aluminium metal. It is also used in making furnace linings, in making ceramics, etc. It's also used as a catalyst in the catalytic cracking of hydrocarbons. Aluminium chloride. This aluminium chloride is prepared on a large scale by heating aluminium falls in a stream of hydrogen chloride, okay, or dry chlorine. So when we heat aluminium with the chlorine gas, we'll have what? Aluminium chloride. Or when we heat aluminium with hydrochloric acid, okay, we would still have aluminium chloride. Okay, so the hydrogen is displaced by the aluminium metal in this second reaction. The next compound of aluminium we have here is aluminium hydroxide. Now, this compound is produced as a precipitate when sodium hydroxide is added to an aqueous solution of aluminium salt. Okay, so when an aluminium salt, okay, reacts with sodium hydroxide, aluminium oxide is produced. Okay, this also a displacement reaction where the sodium is displaced from the sodium hydroxide. All right, so we have the sodium ion here as a byproduct. Now, this compound is also amphoteric, and it is used in the dyeing industry to cause dyes to stick to clothes. Next we have is aluminium tetraoxosulfate 6. Here is the formula for aluminium tetraoxosulfate 6. Now, this compound is a crystalline solid that is moderately soluble in water. So it is not completely soluble in water. It occurs naturally, but it can also be prepared in the laboratory by the reaction of hot concentrated tetraoxosulfate 6 acid on aluminium oxide. So here we have aluminium oxide reacting with tetraoxosulfate 6 acid to give us aluminium tetraoxosulfate 6 and water as a byproduct. This compound of aluminium is used in sewage and water treatments, and is also used in the making of paper. Next, we have aluminium trioxonitrate 5 with this formula. This compound can be prepared by dissolving aluminium oxide in dilute trioxonitrate 5 acid. Now, the salt, of course, the salt is going to crystallize out as what? Monohydrate crystals. This means that it has 9 molecules of water. Okay, this crystal is going to what? Contain 9 molecules of water. So it comes out as what? A monohydrate crystal, which is aluminium nitrate monohydrate. All right, aluminium nitrate monohydrate. It can also be prepared by dissolving aluminium hydroxide in dilute trioxonitrate 5 acid. So aluminium hydroxide reacting with trioxonitrate 5 acid, dilute trioxonitrate 5 acid, is still going to give us aluminium trioxonitrate 5 and water as a byproduct. We're looking at some of the uses of aluminium. We said it is the most abundant element in the earth crust, so it has a wide variety of uses. But we'll just quickly take a look at some of them. Now, aluminium is used in making cooking utensils, such as spoons, pots, boilers, cookers, and pans. As you can see, most of our cooking utensils, our pans, pots, okay, they are made with aluminium, all right? This is because aluminium is cheap, it is widely abundant, okay, so It is quite cheap, all right? It is light, and it is a good conductor of heat. Of course, our pots and pans are good conductors of heat. If not, the heat from the fire will not be able to get through to cook our food. So aluminum is a very good conductor of heat, so it is mainly used in the making of our cooking utensils. Aluminum is also used in making automobiles, aircrafts, trains, marine vessels, trucks, bicycles, spacecrafts, etc. Okay, so it is used also in making of most of our automobiles and their parts. Aluminum is used to produce packaging materials such as popular aluminum foils. We've said that aluminum is light and is cheap, okay, and it doesn't rust easily. So it's a very, very good metal that can be used to wrap our food, our gifts, okay. So it is used in making things like aluminum foils, cans, even some of our drinking cans, and also in making of frames. Aluminum is used in making of food and beverage containers because of its high resistance to corrosion, okay. We said it has a thin film of oxide that prevents oxygen and moisture from getting to it. Because of that, it doesn't corrode easily, all right? And we know that when a metal corrodes easily, it is not good to be used on our food items because it's going to introduce poison into the food. So aluminum, because it hardly corrodes, it's a very, very good metal that can be used to make our food cans, our beverage containers, and the rest of them. As you can see, some food and drink containers, for example, are disposable plates, some disposable cups as well, are made with aluminum. Aluminum is used as an alloying agent. So for example, we have an alloy called duralumin, okay? And it's an alloy of aluminum, copper, magnesium, and manganese. All these metals come together to form this alloy. And of course, aluminum is a component of this alloy. We also have another alloy called aluminium bronze, okay? We have the aluminium bronze, which is an alloy of copper and aluminum, okay? And we have magnesium, okay? Which we have here, which is an alloy of aluminum and magnesium. So aluminum serves as a good alloying agent. It is also used in buildings for the construction of windows, doors, roofings, street light poles, etc. Some of our roofings are made with aluminum sheets. Some of our window frames and door frames are also made with what? Aluminum. So it's used in building for the construction of, different parts of the building. Aluminum alloys, okay, as we saw, some alloys of aluminum are used in the production of coins and some of the wristwatches we wear, okay. Aluminum is a highly reflective metal. As we said, it has this white and silvery color, okay. It's a highly reflective metal used in the making of mirrors, reflectors, and heat-resistant clothing for fire fighting. So these are just some of the uses of aluminum. With this, we have come to the end of this lesson. So let's take a quick summary of what we have learned so far. We said that the group 3 elements have 3 valence electrons in their outermost shells. The group 3 elements are boron, aluminium, gallium, indium, and thallium. We also say that aluminum is extracted from bauxite by electrolysis. And we mentioned some compounds of aluminum. Some of the compounds of aluminum are aluminium oxide, aluminium hydroxide, aluminium tetraoxosulfate 6, and aluminium trioxonitrate 5. We also say that aluminum has several uses. Aluminum is used for making cooking utensils, food and beverage containers, materials for building, construction, etc. All right, we'll just take a question to help us remember what we learned in this lesson. In the electrolysis of aluminium, the electrodes are made of dash. A, bauxite. B, argon. C, graphite. Well, the answer to this question is C. Okay, during the course of our lesson, we said that the electrodes are made of graphite. The electrodes present in the electrolysis of aluminium are made of graphite. Okay, with this, we have come to the end of this lesson. Thank you for staying with me.